Good day, everyone. We are the Group 2 and we are tasked to discuss about iron and nickel deposits in the Philippines, as well as mercury, lead, and zinc. But before anything else, let me introduce to you our group mates. Justin Kurt Alonto, Menchi Argilies, Regeline Baila, Emily Biberino, Jill Canda, Ryan Jonaldo, Mariel Galindez, Rachel Lunop, Rico Mira, Eden F. Perez, and Mary Cleades Ogayan. Next slide, please. For the objectives, by the end of the discussion, the students are expected to acquire basic knowledge and understanding about iron and nickel deposits in the Philippines, and widen their perspective about mercury, lead, and zinc deposits present in the Philippines. Next slide, please. So as you can see in the picture, so that is an example of an iron deposit. So later on, we'll be going to further explain iron and what it is all about. So next slide, please. So iron is a lustrous, ductile, malleable, and silver gray metal. It is strongly attracted by a magnet and is itself easily magnetized, and is the fourth most common element in the Earth's crust and the second most abundant metallic element, of which it constitutes about 5% by weight. So I will no longer explain this one since it's self-explanatory. So next slide, please. So here are the principal ore of iron minerals. I think there are 5, and the first one is hematite, or the ferric oxide, with chemical composition of Fe2O3, and it has 69.9% iron. So next we have magnetite, or the ferrous ferric oxide, with the chemical composition of Fe3O4. It contains 72.4% iron. Next slide, please. Next, we have limonite, or the ferric oxide trihydrate, with the chemical composition of Fe2O3 bonded to 3H2O. And it contains 59.8% iron. And next is goethite, with chemical composition of FeO bonded to OH. With it contains 62.5% iron. And last but not the least, next slide please. Siderite, or the ferrous carbonate, with the chemical composition of FeCO3, and it contains 48.2% iron. Now, in terms of uses, in the United States, almost all of the iron ore that is mined is used for making steel. The same is true throughout the world. Raw iron by itself is not as strong and hard as needed for construction and other purposes. So the raw iron is alloyed with a variety of elements such as tungsten, manganese, nickel, vanadium, and chromium to strengthen and harden it, making useful steel for construction, automobiles, and other forms of transportation such as trucks and trains, and as well as train tracks. So just a bit of fact, guys, iron is valued at approximately $124.52 per dry metric ton unit, or DMTU. Next slide. About 98% of iron ore is used to make steel, which is one of the greatest inventions and most useful materials ever created. So while the other uses for iron ore and iron are only a very small amount of the consumption, they provide excellent examples of the ingenuity and the multitude of uses that humans can create from natural resources. So these are the following are the uses of iron deposits. We have in powdered iron, or in powdered form, It is used in metallurgy products, magnets, high-frequency cores, auto parts, and catalysts. Wherein in radioactive iron or the iron 59, it is used in medicine, tracer elements in biochemical and metallurgical research. Um, in iron blue form, it is used in paints, printing inks, plastics, cosmetics, such as eyeshadow, artist colors, laundry blue paper, and so on. Wherein in black iron oxide, it is used as pigment in polishing compounds, metallurgy, medicine, magnetic inks, and so on and so forth. So those are basically the uses of iron in the industry. Now, the major producers of iron ore include Australia, Brazil, China, India, and Russia. So, however, next slide, please. In the Philippines, iron ores occur in deposits of all geological age or ages. So, the important iron districts of the Philippines are those in Ilocos Norte, Camarines Norte, Cotabato, Nueva Vizcaya, Surigao, include Surigao del Norte and Surigao del Sur, Cagayan Valley, Marinduque, Zamboanga, Samar, Bulacan, and Davao. So those are the places wherein we can find traces or concentrations of iron deposits in the Philippines. Now, the classification of Philippine iron deposits are the following: skarn, magnetite sand rather, laterite, sedimentary, bog, and spring. So this classification of Philippine iron deposits will be further explained to each and every one of us by my group mates.
Okay, so let's move on to the classification of Philippine iron deposits. So first is skarn. It is one of the most important iron deposits in the Philippines. Occurs in a geologic setting in which limestone or calcareous sediments are intruded by a younger intermediate to acidic pluton. The skarn being developed not far from the margins of the intrusive contact into a metasomatized limestone calcareous sedimentary rock. Skarn is a coarse-grained metamorphic rocks that forms by a metasomatism. So it is also called tactites. And then iron in this type of deposits occurs with other metals like gold, copper, lead, and zinc. And then skarn can be used in a variety of gemstone, have been founded in skarn deposits with garnet, ruby, and sapphire being common occurrences in skarn. Also in creating artwork, gemstone, jewelry, metallurgy, flux, and so on. And also, iron skarn deposits occur in Luzon, Central Cordillera, Southern Sierra Madre, Eastern Bicol, Samar, Eastern Mindanao, Mindoro, and so on. So next is magnetite sand. So this deposit type consists of magnetite concentrations in beach and alluvial sand. Economic deposits generally contain 15 to 30% magnetite, which when concentrated yield about 55 to 60% iron. So usually contains impurities of titanium and vanadium which interfere with the smelting process, thus lowering the quality of the iron. So magnetite sand is literally a black sand, indicating high concentration of magnetite in the offshore areas which like sa beach, offshore, like that. And then magnetite is valuable for industrial processes because it helps separate sulfur coal or iron for the steel industry. So next, the most extensive magnetite sand deposits are those along the beaches of northern and northwestern Luzon, eastern Leyte, and southwestern Negros, The deposits in Ilocos Norte are situated inland within sand dunes and of raised beaches around Puay Lake. And then those in the Mortis, La Union, extend offshore in Lingayen Bay as submerged sand dunes rich in magnetite. In Pampanga and Bulacan, the magnetite sand deposits are in inland alluvial floodplains. Those in Leyte occur along the eastern coast of island from Palo to the north of Silago to the south. And then the most the most extensive magnetite sand deposits are those along the beaches of northern western Luzon, and then so on. So next is laterite. The iron laterite deposits comprise the superficial 10 to 15 meters of soil over mafic and ultramafic rocks that are exposed in more than 5% of the total land area of the archipelago. The deposits are two types, nickeliferous and aluminous. So in Claver, it is one of the biggest nickel laterite, and that is the example of nickeliferous ang Claver. And then laterite soil is formed in wet and hot tropical areas. Almost all laterites are rusted due to the presence of iron oxides. So, and then, for example of kanang mga iron in laterite as by the product of nickel mining is in Taganito Mining Corporation, Kajanao Mining Corporation, and in Carrascal, and so on. And also, the only aluminous laterite iron deposits that have been explored are those in Bocas Grande and Siargao Island in Surigao del Norte province. The major nickeliferous laterite iron deposits amotong, that's what I've said, ng mga sa Northern Sierra Madre, Zambales Range, Mindoro, Sibuyan Island, and so on. And then, the main characteristics of laterite is this soil is acidic in nature and not capable of retaining moisture. And it is rich in iron and aluminum compounds but poor in lime and silica due to leaching. Also, with the use of manure, crops may be cultivated. And lastly, crops grown are like cashew nuts, rubber, coffee, and tapioca. So,
So moving on, we have the other classification of iron deposits, and we have here the sedimentary or bedded. When we say sedimentary iron deposits, it's in the form of layers of hematite and or magnetite interbedded with sediments. So in terms of mineralization, sedimentary or bedded iron ores occurs within the upper portion of the sandstone, in which up to 3-meter thick horizon of hematite and magnetite has been encountered in this. And then there are only two known deposits here in sedimentary or bedded. We have Kamanlinyugan, Cagayan, and Tinambak, Camarines Sur. So in Cagayan, it is associated with Pliocene or Pleistocene clastics with hematite and magnetite as ore minerals, while in Tinambak deposit, on the other hand, is associated with Cretaceous graywacke and splitic lavas with hematite and minor magnetite and pyrolusite as ore minerals. So the only difference here out between the two is the ore minerals. And next is sedimentary bag. The deposits consist principally of limonite with minor amount of hematite. So Limonite bog iron ores occurs in small low-grade deposits with much manganese, phosphorus, water, clay, and other impurities. So here, in terms of mineralization, the deposit formed within a structural basin that probably ponded into a lake. Iron supplied into this basin originated from the chemical weathering of surrounding rocks, which shows evidence of pyroticization probably brought about by diuretic intrusions or bacterial actions causes the precipitations of ferric oxides and hydroxides from the breakdown of humic iron complexes and ferrous bicarbonate. So here, the supplies of iron are transported to the bagged waters by streams and springs. At present, bag ores or are very minor economic significance. At least one relatively important bag iron sedimentary deposit occurs in the Philippines are found in Taan Nueva Vizcaya. And last classifications of iron deposits is the spring. The spring iron deposits are considered to have originated as spring emanations in quaternary volcanic terrain. And there are at least three localities that are identified. Here, first is Pandi Azúcar Island of Iloilo, and second is in Binalbaga, Negros Occidental, and third is in Landayo, Tupi, Cotabato. So, the Pandi, Azúcar, and Banalbagan deposits are mainly limonite and boulder coating exhibiting colloidal textures like crustiform banding and botryoidal textures. On the other hand, the Landayo deposits are principally geotite and hematite associated with highly silicified andesite and jasperoid. Um, that would be that. And next is the distribution map of iron deposits in the Philippines. So here we have the distribution all over the Philippines. We could see that in region A we have dili na nako iko. I should not makita naman nato ni. So that would be
And now let's proceed to the second mineral deposit, which is nickel. What you see on your screen is an ore of nickel, which is garnierite. Garnierite is a major nickel ore. It's hydrous nickel silicate with a serpentine group of minerals. It is an alteration of olivine serpentine rocks and can be associated with olivine, serpentine, chromite, and talc. Garnierite is mined from laterite deposits formed by weathering and secondary mineralization of igneous rocks. The nickel is contained in the blue-green bands of the ore in the photo. The specific gravity of this mineral ranges from 2.3 to 2.8. So nickel is a silvery white magnetic metallic element used chiefly in making alloys, was used as a coinage in nickel-copper alloys for several thousands of years. This metal is hard, malleable, and ductile, capable of taking a high polish. It was recognized as an elemental substance only in 1751 when the Swedish chemist Baron Axel Frederick Bronsted isolated the metal from nickelite ore. Nickel occurs as a metal in meteors. Combined with other elements, it occurs in terrestrial minerals such as garnierite, melurite, nickelite, pentlandite, and ferrotite. The latter two minerals are the principal ores of nickel. Nickel ranks about 22nd in the natural abundance among elements in crustal rocks. With regards to its uses, the metal is used as a protective and ornamental coating for metals that are susceptible to corrosion, for example, iron and steel. Nickel steel containing about 2 to 4% nickel is used to automobile parts such as axles, crankshafts, gears, valves, and rods in the machine parts and an armor plate. Nickel is also a key component of nickel-cadmium batteries. Finely divided nickel absorbs 17 times its own volume of hydrogen and is used as a catalyst in many processes, including the hydrogenation of oils. A common byproduct of nickel laterite deposits is cobalt, also a silvery white metal discovered in 1735 by the Swedish chemist George Brandt. Although it is also used chiefly for making alloys like nickel, cobalt has very low ductility at low temperatures. Cobalt 60, the most important isotope of this element, is used extensively in industry and in radioisotope therapy. Productive nickel deposits in the world occur as sulfides and laterites. Both types occur in the Philippines, but the laterite deposits have been historically more economic than the sulfide deposits. Many nickel laterites also contain economically recoverable grades of cobalt. From a geoscientific perspective, the occurrence of nickel mineralization in the Philippines can be further classified in the table shown here. We have, as you can see, we have the types of nickel mineralization in the Philippines. So we have two classifications. They have the sulfide laterite, of course, its origin. For the sulfide, we have magmatic segregation and hydrothermal, and for lateritic nickel ore, residual concentration. And you will know all of these later on during the next slides or next presentations. The most productive and important type of deposit occurs as nickeliferous laterite deposits overlying ultramafic rocks in the country. Such deposits have been exploited in Surigao, Palawan, and Samar. The magnetic nickel sulfide deposit, best exemplified by Acoje, Santa Cruz, Zambales, was briefly mined in the 1970s. Its important byproducts include platinum group of metals, gold, and copper. The hydrothermal nickel-bearing vein deposits in Leyte and Ilocos Norte are both hosted partially or in full by ultramafic rocks. The latter had been exploited as a copper deposit. The attractiveness of the Philippines for nickel mining not only lies in its large nickel resource base, but also in its byproducts. Nickel sulfide deposits are associated with copper, gold, and platinum group of metals, while nickel laterite deposits contain appreciable amounts of cobalt. This huge potential of nickel mining in the Philippines contributed to the successful operation of many mines for long periods. Next, we have the presentation of the classification of nickel deposit types in the Philippines.
So the first classification is the nickel laterite. Nickel laterite is the term used to describe the nickel deposits commonly found in tropical areas where nickel-bearing ultramafic rocks have been weathered. They are usually shallow deposits and often in tropical areas of high rainfall. As nickel moves deeper because of the leaching or weathering, it is transported and concentrated towards the bottom of the deposit or towards the layers in the deposit. Nickel laterite is the major source of nickel in the Philippines. Next, please. Most deposits tend to be capped by a zone of iron oxide or hydroxide clays named the limonitic zone. Most metals other than iron have been removed from this layer during weathering. As you get deeper into the layer, nickel concentrations usually increase. Its color is light brown to brown or yellowish brown. Limonite zone is high in nickel and low in iron. Next, please. The deepest layer of a laterite deposit is the saprolite layer. The saprolite layer is very close to the bedrock. The term saprolite is derived from Greek and literally means rotten rock. Saprolite tends to be enriched in aluminum silicate clays like kaolinite. Its color is commonly some shade of red or brown. As mentioned above, nickel leaches downwards, so the highest grades in a nickel laterite deposit tends to be towards the bottom in the saprolitic layer. Saprolite zone is high in iron and low in nickel.
So let us continue the topic about the nickel deposits. The assigned topic that I am going to discuss tonight are magmatic nickel sulfide deposits and hydrothermal nickel sulfide deposits. So, magmatic nickel sulfide is closely associated with chromatites and platinum group elements, or known as the PGE. So, the chromites, which means the magmatic chromites deposits, are the only source of chromium for industrial use, and in some cases, they may carry sub-economic to economic amounts of PGE. So, which means the platinum group of elements that are palladium, rhodium, osmium, iridium, and etc. So, that PGE are used primarily in industrial applications and have established in chemical, electrical, and electronic engineering. To sum up,
No.
of the manufacture of the number of consumer products and the important role they play in several processes, especially in these modern engineering technologies. So, according to Bakota 1989, which reported four events such as um, bases, basal diabase, and cumulate Harb's Burgate fault. So those are the four occurrences that we can found in Akuhi block of the Zambales ophiolite. So and those and according to Santos on 1993 that Akuhi nickel sulfide deposit best exemplifies the typical magmatic nickel sulfide based on the source that I read that it was formed as immiscibility of a crystallization of magma. So, and according to Abrahano 1989, he believed that it was formed as a result sa liquid sulfide of a crystallization of magma. And talking about the nickel sulfide in our country, here in our country, the nickel sulfide deposits have an average grade of from 0.23 to 0.47% nickel. So, however, next slide please. However, according to Bakota 1989 and Yumol et al. On 1993, they found evidences to believe that the deposit was formed from multiple stages of magma melting processes. Then next, the hydrothermal nickel sulfide deposits. So these are found in narrow silicified zones in serpentinite rock and in rocks. So those deposits that are found in hydrothermal nickel sulfide deposits are 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 to be epithermal, which means that they are commonly found in island, volcanic, continental arcs associated with subduction. So these are the deposits that form at shallow deeps. So we can find the deposits at the shallow deeps only. Then deposited from warm waters and rather shallow deep under conditions in the lower ranges or the temperature and pressure. Then according sa metallogenic model that it involves hydrothermal fluids leaching nickel metal from serpentinite and nickel along with other metals depositing along sa fractures The hydrothermal engine was propelled by heat sources which discovered near these vents. Then nickel found not just in nickel sulfides, but also in iron-rich sulfides. So the copper minerals are also be found as either secondary or main ore minerals. So like energite, tenatite, and tetrahedrite are high sulfidation copper minerals that are found in Pasokin according to Tupas 1952. Next slide, please. Palihog. So according to Jaro, sa Leyte deposit in particular is located fewer than 10 aerial kilometers east of a known geothermal possibility. At turn, the occurrence in Pasikin sa Ilocos Norte occurs adjacent a serpentine lithogranite intrusion. That's all.
And here's the different locations of the nickel occurrences in the Philippines. In Luzon, we have the Casiguran Prospect, the Acoje, magmatic and lateritic deposits, the Mindex, and in Palawan, we have the Rio Tuba and the Berong Prospect. In Visayas, we have the Romblon Prospect, the Giwan Prospect, Homonhon, and the Homonhon Prospect. In Mindanao, we have the Opal Prospect, Pujada Prospect, and in Taganito, in Surigao del Norte, as well as Carrascal in Surigao del Sur.
Okay, so as iron deposits and nickel deposits are already explained, let's now move on to the next topic, which is the heavy metals. So the mercury, the lead, and the zinc. So first, let's tackle the mercury. So mercury, maybe I am not just the one who thought how dangerous this heavy metal is, as we even considered mercury as the most toxic heavy metal in the environment. So for us to know more what's in mercury and how this metal being helpful to us behind its toxicity, let's explain and find out first the properties of mercury. So take note that mercury is not a mineral. Mercury is the only naturally occurring liquid metal at room temperature. Since it lacks a crystal structure, mercury is technically not a mineral, but is a mineraloid. Okay, so mercury is officially classed as mineral species for historical reasons, and also because it is distinctive in its chemical and physical properties. However, because it occurs as a liquid, it does not satisfy the normal criteria to be a valid mineral. So pure mercury is found in volcanic rocks, but mercury usually occurs in the mineral cinnabar or mercury sulfide. So as you can see in the picture, that's the principal ore of mercury, which is the cinnabar. So cinnabar is mined in Russia, Mexico, Spain, and Algeria. So there are more than 25 known minerals containing mercury, but the principal ore of mineral is cinnabar. As you can see in the next slide, please. Okay, so as you can see in the table, that is the physical properties of cinnabar. Cinnabar, which is the chemical composition, is mercury and sulfide. So it contains 86.22% of mercury. It's the chief mercury mineral, occurs in a wide variety of environment and lithologic units, but most preferably in rocks that are porous, fractured, and with sufficient permeability to allow passage of ore solutions or vapors. So I will not further explain the table. Next, please. So for the introduction, so a mercury is a heavy, dense, silvery metallic mineral with a specific gravity of 13.6 and an atomic number of 80. And mercury, like what I said a while ago, is liquid in liquid form at room temperature and becomes solid at negative 40 degrees Fahrenheit. So what does this liquid form mean? So mercury is the only elemental metal that is liquid at room temperature. Why is this so? Because mercury has a unique electron configuration, which strongly resists removal of an electron, making it behave similarly to noble gas elements. As a result, mercury forms weak bonds, and as is a liquid at room temperature. And mercury is also known by the popular name quicksilver, derived from the Greek words hydros, which means water, and argyros, which means silver. The term native mercury is used for natural mercury found associated with the mineral cinnabar. And just a trivia, Mercury gets its name from the planet Mercury, which was named after the swift messenger of the Roman gods, Mercury. So Mercury was also among the first metals known, and its compounds have been used throughout history. Archaeologists found mercury in an Egyptian tomb dating from 1500 before Common Era. And the Egyptians and the Chinese may have been using cinnabar as a red pigment for centuries before the birth. So, di ba, as I said a while ago, mercury is a toxic heavy metal. So, mercury or CH3Hg is actually the most toxic form of mercury. It affects the immune system, alters genetic and enzyme systems, and damages the nervous system, including coordination and the sense of touch, taste, and sight. But despite of this, let's still dig in and find out the uses of mercury. Next slide, please.
So let's proceed to the properties and uses of a mercury. So the first properties is liquid metal. Liquid metal is a metal alloy in which is liquid at or near room temperature. The only stable liquid elemental metal at room temperature is mercury, which is molten above negative 38.8 degree Celsius. So the typical uses of liquid metals include barometers and blood pressure cuffs. The second one is expands and contracts with temperature. The uses of this second properties is thermometers. Mercury's volume coefficient of expansion is 0.0018, so it expands by 0.018% in volume for every degree of temperature increase. So mercury thermometer contains a reservoir of the metal and a thin glass capillary into which it can expand. A third is conduct electricity. Mercury is a poor conductor of heat, but it is a fair conductor of electricity. So, in this property, ang uses dani is switches, fluorescent bulbs, electrolyte production of chlorine. Next is amalgamates with other metals. Then, and uses of these properties is dental fillings and gold purifications. So, almost all metals can form amalgams with mercury, the notable exceptions being iron, platinum, tungsten, and tantalum. Silver mercury amalgams are important in dentistry, and gold mercury amalgam is used in the extraction of gold from ore. The last one is kills bacteria and fungi. So the heavy metal mercury has been widely used as an antimicrobial agent for treatment of bacterial and fungal infection. So ang uses daan is disinfectants and preservation. Next slide, please. So 35% of the worldwide production of mercury is used in the manufacture of chlorine and caustic soda. So chlorine and caustic soda are among the top 10 chemicals produced in the world. They are involved in the manufactures of a wide variety of products used in day-to-day life, including the pharmaceuticals, detergents, deodorants, disinfectants, herbicides, pesticides, and plastics. Next is 30% of the mercury is useful in electronics and electrical applications because before, mercury was an important ingredient in batteries, but sa karon na the newer types of batteries kanang nagamit na siya ng other metals. Then the remaining 35% of mercury usage is in scientific measuring instruments such as thermometers and barometers and is combined with other metals and used for fillings for teeth called amalgam by dentists. So amalgam has been used in dentistry since about 150 years, and it's still being used due to its low cost, ease of application, strength, durability, and bacteriostatic effect. So historically, mercury was used to obtain gold from placer gold deposits, but this process is no longer widely used. So before, sa Western United States, miners use mercury to recover gold. But because mercury contamination from historical gold mines represents a potential risk to human health and environment, mao to si na si ginagamit karon. Then next is major world producers of mercury are in Algeria, Kyrgyzstan, Spain, and China. Next slide. So, geology and mineralizations, including occurrence, classification, and distribution. George H. Newman of Marsman and Company first discovered mercury at Barangay Tagboros at Puerto Princesa in 1938. Then, the first discovered mercury is at Barangay Tagboros at Puerto Princesa in 1938. Nearby mineralized areas were reported at Tagboros by mining engineer Irving in 1954, at Taglamayon by Gio Santiago and R.R. Santos in 1965. Next is the ore found in Central Palawan appears to be the only one economic significance. Next.
So mercury deposits in the Philippines. So as you can see in the table, that is the cinnabar deposits of Palawan. So mainly, the mercury deposits in the Philippines are located in Palawan, which is, yes, the cinnabar deposit. However, the production was stopped. The perpetual and NW deposits, the production is stopped, and the Palawan Quicksilver Mines and Corporation, the operation was also abandoned. And I still don't know kung naababay line other operation of cinnabar in our country as of now. So that's all for mercury. Next, please.
So, after the discussions on iron and nickel deposits and mercury, the last topic that we're about to discuss is focused in the important concepts regarding lead and zinc, its principal ores, some of its important properties, its uses, and occurrences of lead and zinc deposits in the Philippines. So, let's start off by observing this lead zinc ore specimen shown in this presentation. So, the silver gray there is galena and sometimes called the lead glans, which is the natural mineral formed from lead sulfide, and it is known to be the principal ore of lead. The other one is sphalerite slash zinc blend slash blackjack slash rubyjack, which is the natural mineral formed from zinc sulfide and has been described to be having a mottled brownish gray color. It's like a dull gray color there, but other sphalerites are dark black, which is often called the blackjack, while others are reddish to brown, yellow, and sometimes yellow-green. The whitish gray color there is the mineral quartz. But in most instances, galena and sphalerite are often quite similar in appearance, so to really distinguish these two, if they come up to be so similar, especially that these ores are often found associated with one another, is through drop test solutions such as ammonium carbonate. If the solution turns out white, it means it's lead. Ammonium sulfide, lead if it turns into black precipitate, and in potassium iodide, it is considered to be lead if it's bright yellow color. So, to thoroughly examine its chemical properties, it is through those solutions, aside from its physical properties, which will be presented later as we go along with our discussion. So here, it has been said that lead and zinc are the most essential non-ferrous minerals next to copper. So this is maybe because of their unique properties that makes them useful in today's industries. Like for example in lead. So this metal is malleable, which makes it become useful in the production of bullets, in batteries, in architectural metals, and many others. Also, galena, the principal ore of lead, is known to be essentially the source of silver, and since it has high mechanical and electrical conductivity, it becomes useful in the making of electronic devices and also on some silverwares and even in jewelries. On the other hand, on the part of zinc, it also has many uses, which will be then discussed thoroughly as we proceed. So, to give each of us a glimpse, since zinc is an alloying metal, we usually utilize it as an abrasive agent, and similarly to lead, it also has a component to make batteries. So, despite their chemical dissimilarity, geological conditions favored their formation together, and this is a natural preference. So metals like lead and zinc are tend to be found associated with their ores, especially that these two are commonly sulfide ores of heavy metals. So in most areas, lead and zinc are byproducts of gold and copper mining, and sometimes this occurs in trace amounts. So on the other hand, as byproducts, the tailings are processed to recover these metals. The chief, the chief or principal ores are galena and sphalerite, and its occurrence is on porphyry copper or mesothermal vein deposits, meaning it at moderate temperatures and pressures, along with the fissures on the openings of rocks, through deposition in intermediate depths from hydrothermal fluids or on massive volcanogenic sulfide deposits. So these are created with the aid of volcanic associated hydrothermal events in submarine environment. So, in simplest words, this usually occurs in two types of ore deposit. The primary veins known as rakes, and the secondary which happens through the weathering of those primary veins, for example on limestones, also on volcanic rocks and in lodes and stringers. So, its principal ores. Galena as the ore of lead and sphalerite as the principal ore of zinc. And we can best describe this through its properties. So both are classified as sulfides. And in terms of color, galena has a bright silver with a metallic luster but tarnishes when exposed to air, while sphalerite can be yellow, brown, black, red, green or white or colorless. In terms of streak, galena streak is from lead gray to black, while in sphalerite, it is from white to yellowish brown. So galena's luster is metallic when it's freshly cut, but becomes dull gray as it tarnishes with air. So sphalerite, on the other hand, is non-metallic, submetallic or resinous and or adamantine. As for galena's affinity, it's opaque, has a perfect cubic cleavage with three directions at right angles and can be scratched by a fingernail, but is denser. On the other hand, sphalerite's affinity is transparent to translucent with a perfect dodecahedral or in six directions and can be scratched by a copper coin but is less dense compared to galena. So these are the unique properties that each one has which distinguish them from one another. So having presented the properties of its principal ores, the galena and sphalerite, let's put our focus on to the lead itself. So just a short introduction to lead. Its Pb symbol originates from the Latin word plumbum, meaning lead, for it was used by ancient Romans in the making of water pipes. But in other authors, plumbum also means liquid silver and sometimes used to refer to soft metals more generally. So lead is a heavy metal so soft that it can be scratched with a fingernail or cut with a knife, but it is at the same time malleable, meaning it can be formed into other shapes without breaking or cracking, like rolling into a sheet. It can also be drawn into a wire, so it is considerably ductile and is probably the earliest discovered metal that does not occur naturally in its pure state. So it's found in ores with other metals like the galena, which is often found in association with sphalerite. So that's it. By the way, here's a little trivia or fun fact. It is that pencils do not and never did contain lead. So the lead that we have known in pencils is actually graphite, which was mistakenly assumed to be lead in England at their time when they have discovered the large graphite deposits. That's why it's termed to be lead. And also, lead is poisonous, but back in the early times, it is used in cosmetics like in the white lead paint makeup of the very famous Queen Elizabeth, which is speculated that leads her to death. So most probably with a long-term contact with lead. So nowadays, it is advisable to wash hands thoroughly after touching ores that contain lead, such as galena, and not to touch anything like our eyes to avoid lead poisoning. So this is the physical and chemical properties of lead in its pure form. So in pure form, the lead metal is silver in appearance, and as metal oxidizes, it turns to bluish or dull gray when exposed to air. It is soft enough to be scratched with a fingernail, and it is dense, malleable, and readily fusible. Its properties include a low melting point, ease of casting, high density, low strength, ease of fabrication, acid resistance, electrochemical reaction with sulfuric acid, chemical stability in air, water, and soils, and the ability to attenuate. Attenuate meaning reduce the effect of sound waves, atomic radiation, and mechanical vibration. And that's it. So the data says it all. So we must have to take note of this and we can proceed. Anyway, we have discussed most of this earlier already. So we must remember that lead is found in nature and rarely comes in pure state, but most of the time it's associated with other minerals. So I guess that's it for my part. The following slide will be discussed by Emily.
So let's move on. Let's move on to the physical and chemical nature of lead and lead compounds. So lead in its compound form also has many uses in manufacturing processes, primarily as pigments. Lead compounds can be classified into the following general categories. So first is organolead compounds, lead oxides, lead sulfides, and lead salts. So each of these classes of lead compounds is discussed briefly. So the first is organolead compounds. So organolead compounds is a chemical compound containing a chemical bond between carbon and lead. Also, it is a substance in which at least one lead carbon bond. So only two types of organolead compounds have found large-scale commercial applications. So the tetramethyllead or TML and tetraethyllead or TL. So both TML and TEL were once manufactured in large quantities in the United States because they were used extensively in automotive gasoline. Then the second is lead oxides. So lead oxides is a general term and includes lead monoxide or lead-targe, lead tetraoxide or red lead or PB304, and black or gray oxide, which is a mixture of 70% of lead monoxide and 30% of metallic lead. So when we say lead-targe, is a use primarily in manufacture of various ceramic products because of its electrical and electronic properties. Lead-targe is also used in capacitors and electrophotographic plates, as well as in ferromagnetic and ferroelectric materials. So then sa lead tetraoxide or ang red lead is a brilliant orange red pigment. It is used as a pigment in anti-corrosion paints for steel surfaces. Then Also, the black lead is made for specific use in the manufacture of lead acid storage batteries. Then the third is lead sulfides. So lead sulfides or PBS or galena is one of the most common lead minerals appearing black and opaque. It is an efficient heat conductor and has semiconductor properties, making it is desirable for use in photoelectric cells. So lead sulfides is used in ceramics, infrared radiation detectors, and ceramic glaze. And lastly is lead salts. So many lead salts are colored and therefore are used commercially as pigments. So basic lead carbonate, basic lead sulfate, and basic lead silicates are well known as white pigments. So when we say basic lead carbonate, carbonate is used as a component of ceramic glaze, as curing agent with peroxides to form improved polyethylene wire insulation. Then when we say also the basic lead sulfate helps provide efficient long-term economic heat stability to flexible and rigid PVC. Also, the basic lead silicates are used by the glass, ceramic, paint, rubber, and plastic industries. So next, please. So let's proceed to the introduction of zinc or Zn. Zinc is a brittle, crystalline, bluish-white metal and is principally mined as a primary sulfide sphalerite, usually associated with galena. So sphalerite contains 67% of zinc and often includes traces of cadmium, gallium, germanium, and indium as a simple sulfides in the solid solution. So when we say sphalerite, it is our primary source of zinc, which is an important alloy in the manufacturing of metals. So the secondary metals, willemite, smithsonite, and hemimorphite also occur as ore. So willemite, it is a zinc silicate mineral and a minor ore of zinc. It is highly fluorescent under shortwave ultraviolet light, while the smithsonite, also known as zinc spar, is a zinc carbonate mineral that is most commonly found in batrioidal. And lastly is the hemimorphite, is a component of mineral calamine. It is a silicate mineral that together with smithsonite has been historically mined from the upper parts of zinc and lead ores. So zinc readily combines with the other metals forming alloys. For the brass is a copper and zinc, bronze is copper, tin, and zinc, and the nickel silver is a copper, nickel, and zinc. So, okay, next, please. Then the physical properties of zinc. So, the density of zinc is 7.13 grams per cubic centimeter, and the color is bluish white. Melting point is 420 degrees Celsius. Then elasticity and malleability increase when heated to approximately 100 degrees Celsius, boiling point of 906 degrees Celsius, a temperature above 200 degrees Celsius. Then zinc also is a high heat capacity and heat conductivity, and also the zinc is a good conductor. Okay, next please. Then the uses of lead. So it is used in a storage batteries, in sheeting electric cables, in the industry for lining pipes, mga tanks, and exhaust apparatus, and also used extensively as protective shielding for the radioactive material because of its high density and nuclear properties. Okay, next please. And the last is the uses of zinc. So the uses of zinc is used principally as a protective coating and galvanizer for iron and steel, as an ingredient of various alloys, especially brass, as splits for dry electric cells, and many more. So when we say zinc oxide, it's known as zinc white or Chinese white. So it is used as a paint pigment. It is also used as a as a filler in rubber tires and is employed in medicine as an antiseptic ointment. So then zinc chloride is used as a wood preservative and as a soldering fluid. And lastly is the zinc sulfide is used also in applications involving electroluminescent photoconductivity and the semiconductivity and has other electronic uses. It is employed as a phosphor for the screens of television tubes and the fluorescence coating. So that's all for my part.
Okay, we are now proceed to lead and zinc in the Philippines. So lead and zinc in the Philippines are often associated with copper mineralization. So the most important deposits occur as volcanogenic massive sulfide deposits associated with ophiolitic terrains or old mature arcs in the archipelago, as sulfide veins related to hydrothermal mineralization or within polymetallic skarn deposits within metasomatized calcareous sediments intruded by a younger intrusive body. So, volcanic associated massive sulfide deposits are predominantly stratiform accumulation of sulfide minerals that precipitate from hydrothermal fluids at or below the seafloor in a wide range of ancient and modern geological settings. They occur within volcanoes, sedimentary stratigraphic successions, and are commonly coeval and coincident with volcanic rocks. As a class, they represent a significant source of the world's copper and other elements, especially this element lead and zinc, that actually include in the volcanogenic massive sulfide deposits. So next. So lead and zinc in VMS type copper deposits or volcanic massive sulfide type copper deposits occur within the massive lenses of dark ore as opposed to yellow or chalcopyrite dominated copper ore. In the Philippines, the Barlo and Amnay deposits represent the volcanic dominated copper zinc deposits, while the Canatuan deposit exemplifies the sedimentary dominated type. Among the copper lead zinc deposits are the Hexbar, Rapu-Rapu, Bagakay, and lesser deposits. So the copper lead zinc deposits are mainly formed during the mid-low temperature hydrothermal activity. Most of the or hosting rock series are carbonate rocks, plastic rocks, and contact zones between the rock mass and surrounding rocks. Such deposits are extremely rare in the interior of an intrusive rock mass. A copper mine located on the western part of Rapu-Rapu Island here in the Philippines, operated by Nippon Kogyo Mining Corporation, that present minerals such as chalcopyrite, chalcocite, including also the malachite, pyrite, and sphalerite. According to the article that I read, the Bagakay mine is a distinct massive sulfide deposit because it is only known copper deposit here in the Philippines containing complex massive sulfide and carbonaceous or with relatively high copper grade in a volcanic setting. It is the only copper prospect in Samar Island which has proved to be of economic importance so far, and it is an iron prospect that has turned out to be copper mine. Okay, next. So lead and zinc bin-type deposits are considered to be hydrothermal in nature. Some occur in areas known for their epithermal gold mineralization, such as in Paracale, Camarines Norte, and the Mazara district, southeastern Mindanao. And other occurrences are in the Suerteng-Tenga deposit in Nazogba, Batangas, and the Ayala deposit in Zamboanga. And we all know that vein deposits include most gold mines, many large silver mines, and a few copper and lead and zinc mines. So grades of gold historically have been in the 13.7 to 17.1 gram ton range with cut of around 8.6 gram ton. Many more recently developed deposits have larger tonnages and lower grades and can be mined economically thanks more efficient mining and milling methods. So mining requires here is adits, drifts, shafts, narrow slope in a lead zinc vein type deposit. If a vein system occurs near the surface, it may be possible to mine by open pit methods, which would greatly reduce mining costs. So that's all for lead and zinc deposits. As you can see in the screen, this is the that is the distribution of aluminum, molybdenum, mercury, lead and zinc deposits in the Philippines. As you can see in the Philippine map, kanang sa legend gani is the square symbol represent molybdenum, the shaded green of square symbol represent lead and zinc, and the star symbol represent aluminum or bauxite. As what I have discussed earlier about lead and zinc deposit in the Philippines, I've discussed about the location where lead and zinc are located, and we actually shown through this map about the distribution of mineral deposit here in the Philippines. And that's all. And that ends our report. I hope everything is understood. Thank you for listening and God bless.